Hi, I wanted to show the state of the project and walk through a few of the prototypes. This was the first main prototype. It had all the features that I thought it would need. It took me about 3 months to make. You can see more of the circuit underneath. So it had not only batteries, it had a battery charger and a wireless charger here using a wireless induction coil. It had 4 push-pull circuits, so each coil had 2 push-pull circuits so that I could change the flow of current on each of them, each of the coils. Then I also had another 2 push-pull circuits for this solenoid here, which this was the valve for here. I put vinegar in there, fill up the air balloon by blowing it up. There'd be baking soda in there. And then once the clam was put in the water, and it had opened up and descended into the water column, I then fired this solenoid so that it released the balloon, so the vinegar went down to the baking soda and then filled a bladder that was connected to here. You can see, well, here's the AT Mega, here's the thermistor, there's a Bluetooth module under there. It was neat. It was a pretty cool attempt. I think I'm really happy I made it, but I'm very sad that it burnt out and it was pretty demoralizing. I learned a lot from it, and for the next one, I tried to strip down the electronics and I didn't have batteries in here. I just was going to have it, I wasn't going to have the bladder either. It was just focused on the solenoid. Here's the top piece. I had, each coil has 2 push-pull circuits. This one also burnt out during testing, not in the water, but I made a very newbie mistake with the coils. It's absolutely imperative to have 2 Zener diodes in parallel with the coil so that when you turn off the current and the magnetic field collapses, that induced current has a place to flow. If you don't do that, it'll just build up the voltage until it can flow. In that case, it meant burnt out some of the MOSFETs and burnt out the clam, which is also really demoralizing. But is the main reason for why I'm pushing it to move to a 3D printed design, so that I don't lose like months worth of work during testing. I can always just print out a new design. So here are the parts for the new design. Here's the teeth. I've used this shell because it just aids with the process where I like the idea I can look through it. Plus, I'm still figuring out the placement, so I'm not ready to print it all as one integrated shell. Here are the solenoids. This one hasn't been epoxied yet because I need to place it and figure out if the coil is too long. I think it may be a little bit long, the resistance might be too high. So I just want to change that. This one I know is what I want. Here is the pump chamber, which has 2 valves. They're just diaphragms from my respirator. I 3D printed the ring to retain the diaphragm. So basically a copy of what is on the respirator. And I just have 2 of them so that air or water can only flow in one direction when it's squeezed. And you can see it right there, diaphragm. It looks a little sloppy. I gotta get a better process for making the pump chamber. Here, you can see it working. And the goal is basically just to make essentially a pump for the first one. I need to pump the water so that I can get flow over here. So this is going to go in a silicone tube on the outflow valve of here, so that you have water flow across this elastic tubing. This is how you measure total dissolved gas. This is elastic tubing. It's it's silicone. There's a long length of it, so there's a lot of surface area, thin membrane so that gas can permeate through the silicone. So you can measure that pressure. Oops. So you can measure that pressure using the sensor, and this just popped out. That's unfortunate. I gotta go pop that back in. Oh, there we go. And that's how that's how this heterometer works, essentially. So yeah, so that's the current state of this. There's a couple things I want to add, like this flex sensor. So there's a little bit of feedback on the positions. Here are the batteries. I'm just going to use an external charger and just have it so I can cut into the silicone so that I can recharge it without having a built-in charger for right now. That's just going to reduce some of the complication. Anyway, yeah, I'm going to keep working on this and keep updating.